Understanding synaptic pruning in the brain. Synaptic pruning is a natural process where the brain eliminates extra neurons and synaptic connections during development. It occurs primarily in childhood and adolescence, helping the brain optimize its neural networks for efficiency and functionality. Formation of synaptic connections. In early childhood, the brain forms an abundance of synaptic connections to facilitate learning and adaptation. These connections allow children to process various stimuli and develop foundational cognitive, emotional, and motor skills. Why synaptic pruning is necessary. The overproduction of synapses during early development creates a surplus of connections. Synaptic pruning removes weaker or less used connections while strengthening frequently used ones. This process streamlines brain activity and supports effective learning and memory. The role of experience and environment. Synaptic pruning is influenced by a child's experiences and environment. Activities like learning new skills, engaging in play, and social interactions shape which connections are retained or eliminated, highlighting the importance of enriched environments. Brain regions affected by pruning. Pruning occurs in different brain regions at varying times. For example, the sensory and motor areas are pruned earlier in childhood, while the prefrontal cortex, responsible for decision-making and self-regulation, undergoes pruning during adolescence. Synaptic pruning and cognitive development. Efficient synaptic pruning is essential for cognitive development. It helps refine skills like problem-solving, critical thinking, and language acquisition by strengthening neural pathways linked to these abilities, laying the groundwork for lifelong learning. Impacts of abnormal pruning. Abnormal synaptic pruning can contribute to developmental disorders. Insufficient pruning may lead to conditions like autism, while excessive pruning is linked to schizophrenia. Understanding these processes can aid in early detection and intervention. Advances in neuroscience research. Modern neuroscience explores synaptic pruning's role in brain plasticity and resilience. Researchers aim to understand how this process impacts mental health and learning, opening doors to innovative treatments and therapies. Supporting healthy brain development. Parents and caregivers can support synaptic pruning by providing stimulating environments, promoting healthy sleep patterns, and encouraging diverse activities. These practices enhance the brain's ability to refine its neural networks effectively. Conclusion. A key to brain efficiency. Synaptic pruning is a vital aspect of childhood brain development, shaping how we think, learn, and interact with the world. By understanding this process, we can better support children's growth and pave the way for their cognitive and emotional well-being.